Yeah, so first, thanks, Axonic, for inviting us to tell our story about this topic and to get into this topic and why we choose to do a migration. It's good to get into the domain itself. So today, I'm going to do a bit of an introduction about ETPA, what we try to facilitate in the energy market, where the market is heading to and why speed for us particularly is important, how we implemented the framework and some high-over infrastructure designs, and then I hand the mic to Ahmad to tell you all about the last rimples we can currently do on speed improvements on our platform. So first, a really short introduction about ETPA. We are an electricity exchange, so I'm first curious who is familiar with energy trading, or maybe more specifically on stock trading, for example. Who knows a bit about stock trading? To gauge a bit how deep I need to go. So basically, energy trading is very important because it helps to have a stable electricity system, so specifically electricity. It looks like stock trading, so like trading stocks of Google or ASML or Ahold, whatever. We do basically the same in the energy market, so that's not only in the Netherlands, it's in the whole of Europe. And that is already out there for 20, 25 years, and especially the last 5, 10 years when the renewable energies, so RES stands for renewable energies, are now integrating in our sector. So previously, 20 years ago, the supply was following the demand. So when we at home or big companies in Europe turn up their consumption, we just follow with production on power plants, fossil-based most of the times. But that's changing rapidly, and yeah, we are introduced as a new exchange in this market, so we have multiple different markets in Europe, and we are now integrating into the whole system of Europe. So what we try to do is bring production and consumption together, and basically how everything in the world revolves around money. Also the energy sector, of course, revolves around money. So what to decide, which power plant to switch on, is based on money. Who can produce the cheapest energy or who can consume it where. So for us, the real time, we are basically as an exchange impacting the balance in our system because energy at this big power consumption level in Europe is hard to store. We have a lot of batteries, but we don't have enough batteries to store energy for a complete day in Europe. So basically that whole market mechanism is basically what an exchange does. We bring supply and demand together. We use a pricing principle, and therefore supply and demand are balanced with the big chunks of energy which needs to be exchanged. What we try to do as exchange specifically is we try to lower the barriers to entry. The current barriers with our competitors in the rest of Europe are quite high. And with the usage of the new technologies out there nowadays, we try to lower these barriers in terms of fintech, in terms of the technologies itself with the IT, and of course the integrations with all these assets in the energy market. And therefore, basically democratizing the energy market where it's currently only being run by the big utilities and the big consumers. You see more and more smaller parties like small renewable energy sources, wind farms, solar farms, or even small consumer side applications or electrical vehicles who are taking part of this sector as well. They all make decisions in terms of pricing, and in terms of pricing there is a shortage or a surplus, and they make decisions based on all these price signals, at the end delivering a stable electricity system, which we currently see today. What have we done till now? We try to innovate this whole sector because not necessarily only the energy sector is transitioning, but also the technologies we use in this sector, like the exchange technologies. So already in 2016, when we built the minimal viable product, we were integrating it on top of, we were building it with the Axon Framework, so we are already a quite old user of the framework. We introduced one of a new market, the ex-post in the intraday market in the Netherlands. In 2019, we've built congestion management, which for the Dutch people here is a big topic nowadays. We already built a platform in 2019 to solve for these problems. And the last year and this year, we integrated into the system above us. So you have local markets, every country. And on top of that, there is a market which is combining all these markets into one single European electricity market. How does this look like. So you have all sorts of time domains to trade on electricity. So it's not that you buy a stock of Microsoft and you just wait till it's more valuable and you sell it off again and you make a profit. With electricity, there is no storage. So if you buy it now, you need to consume it now, or if you want to produce it now, you need to sell it to somebody else. So there is no storage, there is no hedging in terms of time. So there are different markets for that. We are currently in the right block, and we're going to move into the left part. So that's basically the future markets, buying electricity for a month from now or a year from now. A bit of a glance on the market itself. So all these countries are integrated over the years into one big single system, which of course electricity is shared between all these countries. And it's not an ordinary startup world where you have a new idea and you just integrate and you have customers and you scale if your business idea is good. It's already an old sector. The electricity system is already out there since 1900 or something. And it's highly regulated. So we have all sorts of different actors interacting with the system. And we are basically in the middle, like every company is saying they're in the middle, right, of the solution. But if you look at it from the perspective, you have, of course, the European Commission, how to integrate all these markets, how to work together in Europe. You have all the national governments in every country. The energy market is regulated differently. Of course, you have market parties generating power or consuming power, and then in the middle, it needs to be transported and it needs to get a price to make sense of what we do, where, and why. So, yeah, it's complex, let's say, to go back to the previous presenter. A bit about how we did the infrastructure. So I highly made it redacted it because it's more complex than it, but just to not give too much glance to ethical hackers. So we are connected to a top level, which is the shared order book in Europe. So all the orders which are created on our platform are sent to a higher level platform, which then gets matched with all the other orders possibly in the rest of Europe to get the best price out there in Europe where it's needed. We have a completely redundant system with multiple apps which can scale horizontally. With all sorts of projections into different microservices to make our system auditable and especially performant, because energy trading is like stock trading, it's high frequency trading. So scalability and performance, basically latency to our exchange and how quick are we able to match orders into trades. That's a very important factor for the users of our platform. So in that case, we designed the infrastructure like this. A couple of key figures. So why did we choose Axon in 2017? It's auditable. Energy markets are heavily regulated, just like the financial markets. So if the regulator comes to us, we want to get all the data from this trader. What did he do, when, why, and how? Because market manipulation or whatever, we should deliver that data in a timely manner, and that the regulator understands what happened in the system and how they did their manipulative behavior to gain from the energy prices, because of course that's not allowed, just like in stock trading. Of course, flexibility, it gives us a lot of flexibility. We started in 2017 as one big monolith with the idea this is not going to sustain for too long, so you need to scale up into different services. That helps as well. Of course, performance, if you design it well, you can be having a high performance system. Of course, eventually consistent, so multiple orders at the same time come in, but who is first? That's a very important factor in trading, and that is being handled with the framework as well. And it allows us to horizontally scale, especially with the Axon Server Enterprise, we can horizontally scale easily and spin up another node to facilitate the high throughput of the system. Currently, we already have over 800 million events in our event store, and we started in 2017 with the first events. We have something like 14 separate services facilitating all the business logic. So, of course, the core trading, orders traded into trades, but also all sorts of other services reporting to the regulator what has been done, why, to the grid operators. They need to know what is going to happen in their grid based on what the parties have traded in the system. Since we are connected to the higher level system in Europe, which all the energy comes together and gets a price and gets matched, we have a lot of data throughput. So basically, these are very simple XML messages with an order, a volume, a price, and a delivery time and a zone. and it's like 20 gigabytes per hour with bursts up to 4,000 orders per second. Yeah, we are connected to 7 external parties like banks. So if parties are trading with each other, it needs to be settled financially as well. It needs to be sent to the TSO for checking if it's possible to be transported. Of course, the higher level systems, so all sorts of services which we need to notify in order to have a stable system at the end in real time. I was not even aware, but when I did the calculation how many tradable products we have at any given moment in time, we have something like 3,000 tradable products at any given moment in time for all the different products we offer currently, and that's going to be expanded even more in the future. Yeah, like I said, we were having a big monolith back in the days when we started, and we migrated into a into the Amazon cloud to give us the possibility to scale up easily, and also to utilize the microservices architecture more easily than with bare metal servers. Yeah, what we've seen the last months especially, but actually the last 2 years, it's already happening. It's really that high frequency trading now comes in. So previously, a couple of years ago, it was just trading, a couple of big players trading around. And now we really see battery parties coming in, solar panel owners coming in. So really the throughput of our system has increased a lot the last months. And I said 800 million, but Ahmad will say that we did a migration, which was starting at 600 million events. And in the meantime, so 2 months, we already got 100 million new events. So it's really now picking up pace in the sector and all these parties which are trading. And currently, most of the services are utilizing, let's say, as a listener, listening to projections. And currently, with new products coming up, we're also going to send back to have this domain splitting sourced to the other and to the main apps again as well. I think for now, to get you guys in topic of the complexity of our sector, and the reason why we migrated will be explained by Ahmad.
Thank you so much, Jorrit, for the amazing overview about our platforms, what we are. So last 2 months, we decided to do something interesting. We decided to change our event store and migrate from Xstream, XML, to CBOR, which is binary. First thing, what is CBOR? So CBOR stands for Concise Object Binary Representation. So it's a JSON, it's a binary serialization based on JSON. So it's a key values, but it's not like JSON text formatted, it's binary and it's visualized using hex. Why? Why would we go to CBOR? We could go to Jackson, to JSON, and it could be a good thing. But as Jorrit mentioned, that in electricity trading market, we rely on time. More time mean more money, and that costs a lot because the trading prices are changing really fast at any moment. So you need a high performance application or system for trading to stay alive at that business. Larger data sets mean that you will have more challenges, slower processing, networking, CPU loads, memory issues that we had. Some of them, like in one of our queries, was throwing a max size limit exceeded. Then we could solve this like a temporary by increasing our memory, but then we realized that we need a change. We need to fix this like for future because we are growing really fast in the event and the data size, and we needed really a solution. What we did, we went to see what's the serializers that's supported by Axon. We used to use the default one, which is Xstream, and Xstream serializer. All of you know that it's based on XML, so more tags, human readable, but it's really large data and really slow. You have also the Jackson one, which really quite fine if you go to JSON, but it's still not the best one from the performance-wise. And you have also the last choice is CBOR, which is really small because it's binary and fast, but the only problem with CBOR, it's not human readable at all. So, you know, with a big data, you could like pick the best option from the speed, especially for us. So we decided to go to the stream choice because you cannot do that every day, right? You cannot change your event store every day. So we decided to go to CBOR. How we did the migration? We did the migration in 2 phases. First phase, we focused on the new events that are coming. We wanted all our new events to be in CBOR. And in the second phase, we changed really the event store and changed our already old data store there. To do that, we had to implement like a custom serializer in all our services. That custom serializer will do always serializing to CBOR. But when it's come to deserialize, it will check the data. If the data is XML, then it will do the deserialization through XML deserializer. Otherwise, it always will be CBOR. The next slide, you see this is the deserializer method. It have a really simple condition. If you can look to the if condition, it's just looking to the first character. So if the first character is a bracket, then we know that it's XML. So you can use the Xstream serializer. Otherwise, you will use the CBOR serializer. This was the first phase. We deployed all our services with this custom serializer, and we start getting all the new events in CBOR. The next phase was more interesting because we needed to change the event store. So we had to change all the events from XML to CBOR. And also it was a great opportunity to get rid of all the upcasters. You know, they are annoying sometimes. So it's an opportunity to take them away. The more challenging thing was that we cannot make a downtime at all. So we had to do it while the application is running. How we could do that? You know that the events are mutable, but always we keep like a backdoor to do these things. And Axon supported the active event transformation. And the active event transformation can allow us to do the edit and to alter, delete, create even a new events. And the active event transformation was supported by Axon since version 2023.10. I will speak a little bit about how the active transformation done. So the active transformation have 2 states. First state is the transform. You do the real transform, but that transform will not be really applied to your real life. So you finish the transformation, then you decide to go with or to cancel. And how that happens, first you fetch the events depend on the tokens. So you can give a range for the events from where to where, and then you apply filters on the events if you have filters. In our case, we did not have any filters. Of course, we applied our upcasters, and we were happy to apply them and take them to the last time. Then we deserialized to XML. We serialized to CBOR. Then we save the new version. And what happens is inside the event store, you will have a new segment for the new event. And that segment will not be used until you say apply or cancel. Of course, it didn't work from the first time. We had a lot of issues and a lot of problems, and we had to cancel in the first million of events, a million of events, because we had a deprecated models already removed, and we did not have them when we start the operation, so it started failing. So we had to bring them back. And also, some of our event models was not really written in a right way. So we had missing default constructors. In marshalling, which is used by Extreme, you don't look for the default constructor because you look to the arc constructor. But in CBOR or Jackson, you need these things like because you will use the sitters and the getters, right? We faced also some issues with the upcasters. we've solved them. And this was really the happy moment that, okay, we finished that. But the also interesting part was that we did 1,000 event per time. So we did it in batches. So we did not want really to put load in Axon or take the whole resources. We wanted Axon to be chill, in chill mode, relaxing on the beach, doing his stuff, and we can just take some of the events, part of the events, doing it and saving it again. The only things also we needed to do is to double the size of the event store, because you know that it will create a new segments, and that's mean no more size, only for the moment that we did the event store changing. And of course, we had to have a database instant because we wanted to keep tracking of our token. We did not want to use the memory one. We applied this change to 680 million event. The total process time was 45 days. So it was really taking it the whole time. We was really not pushing that. After we finished, we saw that our store was changed from 1.1 terabyte to 680 gigabyte. That almost 50% of the store. Imagine how CBOR really affected us from the first moment we applied it. As I mentioned, our storage was reduced at least with 40%. Additionally, we start seeing improvement in the performance, and this has happened because it's binary and it's very small, so in networking area it would be really fast. We could not really measure a time because we did not have like a history measurement for the speed. What is the disadvantages for that? You know, I mentioned that CBOR is not a human readable at all. So if you go to Axon Server UI, you could not even check your data. And usually if you have a problem with an event, you want to see what the event data, try to write a test case for that, right? So we had to implement a plugin. And that plugin, what basically do, intercept the snapshot read or the event read, convert it to JSON, and send it to the Axon UI. And we applied that plugin in our server, in Axon Server UI. The other thing, we already using Java 21, and Axon Server, they're still in Java 17. And as I mentioned, we had a lot of problems for missing bojos because they were deprecated, and also for not well-designed event models. This reference you see was written by Mitchell. It's really amazing. And I recommend to see that if you are going to migrate, at least to CBOR. Yeah, it describes everything in a good and a basic way. That's it.
Thank you very much.
You're welcome.
I see we have a question already in the back.
Hi, nice job. I got a question about the version. Do you have a special version for your CBOR events, or is it just another new version?
It's a new version.
Yeah, okay.
Yeah.
Anyone else?
Yeah, I think you can hear me from here.
Yes.
It was about auditability. So you mentioned you're in a highly regulated industry. Auditability is massive. You're actually rewriting history, but not the facts. You're rewriting the format. Yeah. Did you have to do and jump through any hoops to prove that the history had not factually changed? So no one was pretending that trades looked a certain way back in the day or anything like that.
I don't think we could really do that, but if you check after you finish, you could see if there was a problems or not in your change process. And you have the choice then, if you are confident 100% that it will work, then you press the button. But in events history, I don't think it's something we really check. But what you can do, I think that just something jumped in my mind, that you can like try to replay the events from the old history and have a database cluster. Then yes, reply the events with the new version and compare them. At least this is good. Yeah, yeah, good.
Yeah, from the regulator perspective, it's not there. The market is heavily regulated, but they're not on top of our IT. So,
yeah,
luckily. Otherwise, there's no room for change anywhere because they will say no by definition, right? So. It's also not in our interest to change the history, right? We're not part of the energy market. We're part of the energy market as a facilitator, but how the history evolved, it's not up to our interest or we can gain from it, right? So, yeah, 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 yeah.
Great. Any other? Go ahead.
Hi. Yeah. Hi. Nice talk. Thank you very much. My experience is that Extreme is, serializes in a pretty large form, but it can actually serialize everything, and especially Jackson, that is used underneath, is a little bit picky. So how was your experience regarding this transformation from don't care about how the event looked like towards it could be interesting, and how you maintain that actually all events are serializable and deserializable?
So if I understand you well, you are talking about if we care about adding a new attributes or about the serialization and deserialization, right?
Yeah, I mean, not every class is serializable by Jackson, right? So you need to put additional properties more.
Yes,
maybe,
we had
maybe
to do
some
it.
formats, and then maybe write 200,000 tests. Serialization works, and
we had these problems too much when we was migrating, and we had to fix our event models. So one of the problems was, you know, the Boolean primitive, if you put it with the name is, like starting with is updated, is enabled, and you try to generate the getter and the setter through the IntelliJ, your IDE. So by default, it will be created as is enabled or set enabled. And Jackson will try to look set is enabled, which is not there. So these issues, we had to do it like by hand for multiple of the events. That process was really annoying, but at the end, we could make it, and all the events was really processed well. Yeah, I know that it's extra time, but it's worth to go for it. Thank you.
All right, thank you. Please go ahead.
Hey, I'm just curious about batching processing. You select like 1,000, and what was the influence of the performance? Like, why you didn't go for 2,000 events?
We choose to start with 1,000. That's because it's like a number. We did not do it for like reason in the batch amount. We did not want really to put a load in our Axon server. So we said we are not in a hurry. That's why we can start with 1,000. And we saw that the process was already going well. So we did not change it. We decided to keep on with that. But we did not really feel it. You see it stuck for 45 days. And a normal project like a system, you could take it down for a couple of hours, take the high load, and everything would goes 100% for you, like just a couple of hours. But really, because we have too much events are coming, because Jorrit mentioned that in 2 months, we had 100 million new event. So we did not really want it to put any load at all at Axon. So we decided just to go with 1,000.
Thanks.
Yeah, so it was not really having a constraint on the system, which was the intention. I think it increased the CPU of Axon server to 5% or so, an extra 5%. And with energy trading, it's volatile, very volatile. So dependent on what happens outside with the weather, either there is a lot of trading or not at all. But it's unpredictable from our side what will happen tomorrow, right? Can we increase CPU to 70% and be done quicker? That's just an operational risk from our side that we cannot support the speed in our application. So we just said, well, there is no rush, and let's just move on a decent pace, but not stressing the system to its limits, I would say, in high volatile trading timeframes.
You have a question there? One more. It's a bit unfair maybe because it's more a question for Axonic. Spoiler, we worked with Afro binary encoding. It's a lightning talk this afternoon, and we also had to come up with a plugin to make the events readable. So this is only usable with enterprise server and not with a SaaS solution. So Alert, are you going to fix this?
Yeah, by the way, I already mentioned that to them in the dinner to Mitchell. I already mentioned that we need the plugin to be supported, at least from their side.
You can get our code, right?
Yeah, well, we'll see what the future brings us. Any other questions? Right, then I think that's it. Thank you very much.
Thank you very much.
Thank you so much.
Jorrit.